Welcome back to Geospatial Talks with Mengosa. In today's video, we're moving to the next step of our Landsat workflow using QGIS. I'll show you how to load Landsat 8 and 9 bands imagery into QGIS and then create both true color and false color composites to clearly visualize urban areas, vegetation, and land features. By the end of this video, you'll understand which band to use, why color composites matter, and how to display your Landsat images correctly for urban analysis. If you haven't watched my previous video on how to load free Landsat 8 and 9 images from USGS, please do so. Let's get started. Let's understand what a color composite is. A color composite is created by combining different spectral bands, red, green, and blue, channels to highlight specific land features. For example, false color composite uses bands 6, 5, and 4, where sway is assigned to the red channel and near infrared assigned to green and red to blue. Build-up areas appear brighter and clear, and vegetation appear green or red. This is commonly used for urban expansion and land use analysis. And for true color composite, we use the bands 4, 3, and 2, the red, green, and blue band. And it looks similar to what human eye sees. It's useful for visual interpretation and presentation. The only limitation is that build-up areas are not very distinct. So for our project, we're going to use the full color composite for urban expansion mapping. We're going to learn also why color composite matter in urban studies. Color composite enhances visibility or build up areas, differentiates urban areas from vegetation and water, and also improves accuracy before classification. It helps in change detection across areas. And some of the we are going to install in our QGIS software to help us in creating the color composite, the semi-automatic classification plugin, which provides pre and post processing of Landsat, Sentinel, satellite, and etc. When you load your QGIS software, this is how the work interface looks like. We have the browser panel, we have the layers panel and the map canvas panel, and also we have the main menu panel. So we're going to create a new project by clicking on project and new. Then we're going to save our project as creating color composite. Then click on save. So our project is already saved. In the browser panel, we're going to navigate to where we saved our bands and load them into the QGIS. Click on this drop down. I save the bands at desktop. Then under the JS folder, I have a folder for raw data, and these are the bands. So we're going to load the bands into QGIS. We are going to drag and drop the bands 6, 5, and 4 used to create our false color composite. Drag and drop. That's band 6, band 4, that's band 5, then band 4. So that's how we load our bands into QGIS. Before we continue, let's load a base map just to provide a context for our mapping data. So we're going to navigate panel. We're going to navigate to XZ tiles, and we have this under the drop down. We have OpenStreetMaps. We're going to right click and add layer to project. So this is our Now let's install the SCP plugin, which is going to help us in creating the color composite images. So we're going to click on plugins, then manage and install plugin, and this window will pop up. Then you're going to tap SCP plugin. So mine is already installed. So if you've not installed, you just click on install. So let me close this window, and it appears here, and also the SCP. I'm going to create a false color composite. First, let's rename these bands. Just right click on that layer, then scroll to where rename layer is. Let's create the first composite image. So you're going to click on SCP, then click on band set. In the band set, you're going to click on this plus sign for you to add the bands. Add the bands are done. Then okay. Let's select the bands we're going to use, the band 6, 5, and 4. Then check on this box at the bottom, create raster. Create raster. We're going to save it as output. Select the folder. After the false composite image is produced, you're going to navigate to where we saved it, and I saved it at the output folder, and now we're going to load it into our project by dragging and dropping. And now this is the image. The bright green color represents dense earthy vegetation. The pink, magenta, or the purple color represent the build-up areas, the bare soil, and urban regions. Black regions represent deep water, shadows or not. Let's rename the layer to false color composite image. False color composite. So next we're going to create a true color composite imagery by loading the bands. Band 4, which represents red, band 3 representing green, and band 2 representing blue. So already we have the band 4. I'm going to drag and drop the band 3 and band 2. The band 3 and band 2, and I'm going to rename them. Let me uncheck the false color composite layer and check the band 4, 3, and 2. We are going to click on SCP, then band sets. This window pops, and we're going to click on this plus sign, and we're going to select on the red band 4, 3, and 2, 4, 3, and 2, and click on OK. Then we're going to select this bands, create the true color composite image. So we're going to check also on this box, create raster of bands. Then click on run and navigate to where we're going to save our output, which is the true color composite. The process is running, and a few it will produce the image. Then you're going to close this window and navigate to where we saved our image. On the browser panel under output there, I'm going to drag and drop the true color composite image. So I'm going to use this one as true color composite. true color composite. So the green areas represents the green or dense vegetation. Gray, brown, or light purple areas represent build-up or urban areas, roads, rooftops, and bare soils. The dark blue or the black regions represent water bodies such as lakes, rivers, etc. And the brown to tan areas represent bare land or exposed soil. That's for today's lesson on creating color composites in QGIS using Landsat 8 imagery. In the next video, we'll start analyzing urban areas using indices like NDV and NDBI. If you found this helpful, don't forget to like, subscribe, and turn on notifications. Thank you for watching and see you in the next lesson.